last Pavilion panel, and we certainly saved the best for the last, or last for the best, because as some of you who are regular attendees of the Pavilion panels at DAC, you know this. Lucio Lanza has always been the sage in the industry who has given a lot of us a lot of advice, and so we certainly wanted to make sure that the attraction of attending Lucio's panel or Lucio's advice session was the most interesting part for you towards the end of the exhibit session. So with that, I would like to introduce our panelists today, and of course the topic is a different kind of design automation, which as you would expect from having attended last year's and previous year's sessions, that Lucio always has these interesting topics. So without going into the details of the topic itself, Lucio, who doesn't need much introduction, I will still take a stab at introducing him. He's the managing director of Lanza Tech Ventures, an early stage venture capital and investment firm. Since 2008, he has been a general partner of Redwood Capital LLC, an investor in public technology companies. He has been a non-executive director of ARM until 2010, and is chairman of the board of PDF Solutions, a provider of technology to improve semiconductor manufacturing yields. In August 2010, he joined the board of Harris & Harris Group, a publicly traded venture capital company that invests in nanotechnology and microsystems. He also serves on the board of directors of several private companies. He came to the venture capital industry after executive positions at Olivetti, Intel, Daisy Systems, and Cadence Design Systems. He holds a doctorate in electronic engineering from Politecnico of Milan. Thank you. Okay. Next to him is Warren Savage, CEO of IP Extreme. Warren is well known and perhaps one of the most recognizable figures in the semiconductor industry, which I fully agree with that. He has spent his entire career in Silicon Valley working with leading companies including Fairchild Semiconductor, Tandem Computers, and Synopsys, where he focused on the problem of building a global scalable semiconductor IP business. In 2004, he founded and still leads IP Extreme in the mission of unlocking and monetizing captive intellectual property held within semiconductor companies and making it available to customers all over the world. He holds a BS in computer engineering from Santa Clara University and an MBA from Pepperdine University. Okay. Next to him is Mohammad Qasim, CEO of eFabless. eFabless was founded by Mohammad, a multidisciplinary technologist and 50+ years expert in nanometer, analog, and mixed signal IC design. Prior to launching eFabless, Mohammad was the business manager for TI's OMEM application processor, responsible for the top-line growth for a major OEM. Mohammad held a variety of technical and global leadership posts with TI's wireless business unit. He was responsible for the development of integrated analog and mixed signal IP in 90, 65, 45, and 28 nanometer nodes, starting at technology definition to qualified volume production for wireless SoCs. Mohammad joined TI's Wireless Technology Center unit in 2000 and was elected as a senior member of technical staff in 2006. He holds an MSEE from University of Waterloo, Ontario, Canada, and BSEE with distinct honor from Ain Sham University, Egypt's top school in electronics. All right, and finally another person who also needs no introduction, and therefore I'm still going to do it, which is Ted Vukarovich, CEO and founder of Nconcert Inc. Ted is the founder and CEO of Nconcert Inc. Nconcert is a real-time digital media company with products and solutions that serve the live media streaming market with an emphasis on wearable systems. Prior to Nconcert, Ted served as Senior Vice President and Chief Technology Officer at Cadence Design Systems. He was responsible for driving advanced research and development through strategic technology investment, internal entrepreneurship, and operation of Cadence Labs. Before joining Cadence in 1992, Ted worked 14 years at Analog Devices, where he held roles in manufacturing engineering, chip design and computer-aided design, software engineering. He was co-founder of the Linear Signal Processing Division, where he was responsible for the design and implementation of a complete mixed-signal ASIC CAD environment. Ted received his BS degree in electrical engineering from the University of Arizona. So with that, our luminary panelists and under Lucio's guidance, we'll start the panel. Thank you.
Thank you very much. Well, thank you for being here. We appreciate a lot to see that you are here when we're right at the end of the conference, and we understand where the people stand between you and freedom. So we try to be, if not brief, at least we try to be interesting. So this panel, when I was talking with Yavin and with the organization here, and Yavin, by the way, contributed to this panel incredibly, because I came with one panel and I left with a different panel. So literally, they say, yeah, that's not right. Everybody knows that. Try to do something more interesting. So, but I'll take responsibility anyway. So what the thing that I was thinking at was, it's obvious at this point that Moore's law has been slowing down. It's obvious that the next node doesn't happen in 2 years. It's obvious the next node is not going to be 4 times the density as it used to be when my hair was black. The next node is going to have this incredible different capability. Not even given it's going to be lower cost. Yeah, you're going to have new things, but it's not a given that it's going to shake up this entire design automation conference next time. Different tools, different. I don't think it's going to happen. And in fact, when I was walking around here for the last couple of days, one thing that I noticed, and the impression I had was that there is not too much new tool companies. There are, no offense, I've seen new tool companies, very interesting things, but what was new was this incredible fermentation of IT companies. They're everywhere. They're bubbling up in all these new IP companies. Everybody is a different slant of what they're trying to do. And I was thinking about this, thinking, I'm seeing this strange situation where it used to be, what was IP? Well, fundamentally, most of the time, IP was an implementation of a standard, a new version of a standard, a new standard, and you go in, you do whether it's your USB, your file, whatever it is, you make new IP that way. This thing seems to be different. To me, it's the beginning of a different thing. The source and the origin that says, I need new IP, is not as some committee somewhere has decided to increase the speed of standard XYZ. Is that while it's slowing down, the path of doing billions of transistors is slowing down, and it used to be computers drive and mobiles drive, everything seems to be slowing down from that point of view. What is not slowing down is the number of different fields of mankind and of reality that are being attacked by simple pieces of IP and therefore by simple chips. There is far more used to be, whether you want to call it Internet of Things, whether you want to call it the medical device, sensors, you name them, and there is this stuff that arrives. And suddenly, my shoes, my glasses, whatever it is, everything around now is looked upon as a destination of new pieces of IP or silicon. That is one thing in my mind. I'm going to ask the question. If that is true, which is not a given, but that is true, is it true to conclude that one of the strongest areas of IP that will be attacked in the next generation, next few years, is analog IP? Is the IP that interface with the new fields, the new world, the new application, whether it again is a thermostat or my heart or my hands, doesn't matter. But is that something we should be looking at this point?
Absolutely. I think, well, to concur with your point, Lucio, I think IP is really changing the way this whole semiconductor industry works and allowing for much greater creativity in the types of devices that are available, just because of the amount of creative talent that's being encapsulated in a licensable IP form. I think it's really a significant change over the last 10 years. But I think to your point, it's definitely something that we could be concerned about or excited about, is the new types of technology that are there. And as you mentioned, it's not only it's analog IP, it's RF IP, it's all being driven by communication. and there's a communication layer that's always there. It's pretty. We've had communication for many years, but those type of communication things will apply to the micro level, to the sensor level, and there'll be software implications at every level along the way to how these things talk to each other.
Like a view from a product perspective, whether it's the process technology, whether the IP, the design automation tools, or methodologies, all of that is, or the software on top of all the stack, they are used together to solve a problem. So these problems are practically human, and these are things that we face in our life every day. So the animal component is going to be high. That said, there's a lot of IPs that have been built in the industry so far that have been geared towards standard or towards, I want to get bought by this, I want to hit this deal where I get 100 million units on an IP and I get royalty and I'll be rich, but they don't address the variety of demanding features and whatever it is, new power requirements that would come for localized markets, for small shops, for. So I believe that there will be an analog and there will be a lot of further fermentation of existing IP, whether it's because it's not applicable in some spec, or probably power, maybe cost, and the second aspect is that it's because there's a lot of redundancy. So a lot of that is going to have to stick with the shelf.
Yeah, you have obviously more analog background than I do, so.
Well, I don't know, Lucio. I think Lucio's premise that the marketplace has been understanding that there is an opportunity for diversification of the intellectual property because of market need is absolutely spot on. The analog element of that in terms of diverse applications of traditional analog approaches to problems and the ability now for design teams to actually package that up in a way that's manufacturable by integrating it into larger systems. I think the expertise is there to do that now. And so the market's there, the expertise is there, and you're starting to see the people with the knowledge on how to understand exactly what the market needs now are starting to actually take entrepreneurial steps in that direction. So dead on that. What drives that? And for those of you that might remember me from back in the day when I was actually sitting on your side of the seats, I love gadgets, right? So what's driving it? Okay? Well, have you ever seen one of those? It's a personal drone that you can buy for $300. How about one of these? It's an iBeacon, so that when you get separated from your phone, something beeps to let you know, or maybe your keys have it. Really kind of interesting stuff. How about some of these? Glasses. Kind of interesting the amount of information that now is available to you, not only in auditory form, but also visual form, for real-time improvement of your lifestyle. And what ties them all together on my body? That. Every one of those systems is buildable today. None of them are optimized for how they're trying to be used. That drives the notion of optimization of the system at component pieces and having access to every one of those component pieces. Guess what those component pieces are? IP. So I see a huge world of experimentation exploding in front of your eyes on all levels as people, as Lucio rightly said, not driven from what can I do with twice the number of transistors at half the price, but what can I do with this large volume of know-how to now solve high volume consumer and enterprise solutions in the marketplace. And so it's extremely exciting, and I'm just tickled.
I just want to add something on this. So if you've been to the Maker Faire a couple weeks ago, you will see an incredible amount of innovators coming up with small things, whether it's on the wearable, tennis, fitness performance, whatever it is. Different things are being done. There's an important characteristic of all these people. they don't know what can be done with an IC. All their systems are limited with whatever they have. This is the minimum IP block that they know. And a standard, that's what they know from a system perspective. But imagine you open the platform to a lot of the IC level integration where you can say, I can cut this in half and do this with a couple of things and make it smaller to fit in the glass, for example. So there is a lot of them that don't know what to do, the potential of the products. So there is a problem also for bridging that in the letting the system people know how to apply the IP in their application.
That's exactly right. An explosion of system design starts that require intellectual property.
IC design from all my life, but I've always done an IC design with a high degree of software automation that is not provided by EDA, standard EDA systems. And I would hire software junkies best inside the design team and tell them, you're a designer, let's look at the problem. So I think if you really look at the problem in a new way, you're gonna have to see what you have. You have large stagnation of IP. You have a large different set of needs that are customized to people, whether it's too custom or a smaller solutions. There has to be a bridge to take this to this. So everybody here needs to be looking at how to solve the problem of the new type of demand that is specifically fragmented, actually. A lot of it is going to be fragmented. And be flexible enough to take IPs from one side, convert it to something useful on one side, in a ubiquitous and geographically diverse ways, because it's going to depend on the culture. It's going to depend on, like even the apps now, you can see the same app. It's not about language. It's about how there's a specific business model that works in certain areas. Or some people would actually, you will say about the shoes or what. So everybody will have something, but it is unfair to the industry to say that we don't use what we have, the collateral that we already have. So we need to have a bridge on that. So everybody needs to think about solving the real problem, the product problem, not the IC guy's problem. This is actually something that IC problem is not a problem. The real problem is the human problem. So if we design, if I have anybody here, if I'm make the design automation of an analog or digital or faster, it's not necessarily something that is useful. What's useful is that how do I get to the solution faster and more, and a prototype actually where I can get it to somebody out that can test it and give me feedback on a physical product and then bring it back to me and iterate. This is the kind of process that I'm personally building in our company. This is how we should behave. Very agile, very adaptive to the end consumer need. And I think that it should be the case here.
So I'd like to relate a little story that hit me like a ton of bricks this last fall. We hired a embedded software person for our IP company. This person had a background, they worked for the Monterey Bay Aquarium, did microcoding on tags that were stapled onto sharks. And so he was an embedded programmer. So he came to work for us, he had this background of using chips. And now he's working on IP and we're specifying certain features into the IP. And he came to me and he says, you mean we can specify the features that are available to me as the programmer? He says, this is mind-blowing. He says, I just used to have to use what they gave me. And he says,
the microprocessor.
Yeah. And so to your level of raising the abstraction level, I mean, this starts with the firmware guy being able to specify his processor, and we saw a couple application-specific processor IP companies out there at DAC, and I think this is actually going to go up to the consumer level eventually.
Now, one thing that